So hey guys, and welcome to the Spotlight. So I kind of have explained special relativity in some of my older videos, but this is kind of that crash course into special relativity video, and my objective is to get the most basic understanding of special relativity to you guys. The main focus of this video will be to the most basic concepts of special relativity, and I'll try to not include as much math as I can. Now, the most important thing to understand special relativity is frames of reference, since special relativity is largely based on motion and frames of reference. So check out this video somewhere here or here, a card pops out, click it, that might help. So assuming you know what a frame of reference is, let's get to the most basic understanding of special relativity. So think of light as a really fast train whose speed limit is fixed to 3 into 10 to the power 5 or 300,000 kilometers per second or 3 into 10 to the power 8 meters per second or 299792458 meters per second. Yeah, I remember the value. I'm not reading it off that script. The speed is fixed by station master Einstein. But there's a catch. And the catch is that train can neither go faster nor slower for any observer in any frame of reference. Now let's say you are driving a train and on the track beside you, the train called light passed you, and having an insane reaction time, you measured its speed. And with the gift of the concept of relative velocities, you observe light to be going slower. Well, at least you should, with the conventional understanding of how things work. But that should not happen, and that's the most basic postulate of special relativity. For any frame of reference, the speed of light remains constant. It does not change. It's an invariant quantity, unlike energy. That is where the paradox lies. What Einstein suggested was that the length of the moving body contracted and the time for it to make up for the change in the speed of light for that frame of reference. For understanding it better and making a better mental model, consider this. Let's say you, and along with you a friend, manage to trap a ray of light in an infinite loop where it keeps on reflecting off of two parallel mirrors. Now let's say one of you starts moving. If you observe carefully, part of the light in your friend's frame of reference, not depending upon who is moving, is not straight anymore, but for him it still is. Now considering that the light is bouncing off at equal intervals and the mirrors are spaced equally, you are not measuring the speed of light to be the same. And this is exactly what is impossible according to Einstein. So the length of the path contracts and the time for the moving frame of reference slows down to make up for the illusion of the increased speed of the light. Now the thing to remember is that this is completely relative, just like motion. So like for motion, for an inertial frame of reference, there is absolutely no experiment one can do to identify whether he's moving or not. So if you see an object moving in space, you see it moving because it is moving in space with respect to you, and time dilation and length contraction work in the same way. If someone is moving with respect to you, according to your frame of reference, their time is passing slowly. But for them, it's passing slowly for you, since you are moving according to them. Now our minds, because of the primitive evolutionary instincts, ask the question, well, who is right? Well, no one is. And you both are. That is what relativity is. Time, just like motion, is relative. Now, I can say that I'm not in motion, but someone else can say otherwise. That's the same for time, but it is still a scalar since it cannot run backwards, unlike motion, which is, vector. Well, Earth is not moving relative to me, but it's moving with respect to the astronauts at ISS, and both of us are right. Now, it might seem a bit easy after you've said it a multiple number of times, but you are going to lose it, and I guarantee you're going to lose it. Let me come to my future paradoxes, which are not paradoxes actually. Well, from what we saw, there's a symmetry between both the frames of reference. Now, just to turn the things a bit up, consider this. A very long time ago, there were two twins, and one of them decided to go on a space trip. Now, you would argue that, oh, long time ago they didn't have spaceships, how did they go? Like, give me a break, okay? Well, I know. A break. I know. Give me a break. Now, the twin who went away, let's say he went really fast at, let's say, a quarter of the speed of light. So time dilation and length contraction started to act. Relativity came into play. Now, for the twin on Earth, the twin who went away was in motion, so he aged less. But from the frame of reference of the twin who went zooming away, the twin on the Earth aged less. But when both the twins meet again, who aged less? They both can't age lesser than each other. Now, this is called the twin paradox. And well, it's actually not a paradox, but just a test of your understanding of special relativity, and it's fine. If you didn't get the paradox, it's fine. It's not a test of you. Now, to solve this, I would have used Minkowski's diagram of explanation, but since that's enough a big topic for another video, I'll make it simpler. I'll make another video about this diagram, Lorentz transformation, Galilean transformation, to make it a bit simpler. But the paradoxical question arises when we consider that there's a symmetry between both the frames of reference. But the thing is, there isn't. Since the twin who went zooming away, let's say Tsiolkovsky, and let the twin on Earth be called Minkowski because honestly, they need names. So Tsiolkovsky went away, actually changed his inertial frames of reference when he was deaccelerating and accelerating towards Earth, when he wanted to return back. So there isn't a symmetry between both the twins, since both of them weren't in a single inertial frame. Now you would argue that for Tsiolkovsky, Minkowski also changed frame of reference because for him he accelerated. But an inertial frame is not relative to anyone. An inertial frame is when you change your velocity with respect to the whole of the rest of the universe. That's what an non-inertial frame means. So in reality, if both of them were to ping each other their ages and how they have aged throughout the journey, Minkowski would see Tsiolkovsky aging slowly for 90% of the journey and again faster for only 10% of the journey, while Tsiolkovsky would see Minkowski aging rapidly for 50% of the journey. Well, this is a bit hard to understand without the diagram, but you can consider the answer to this paradox to be, well, since there isn't a symmetry between both the twins, since one of them entered a non-inertial frame of reference to enter another inertial reference, we cannot draw a symmetrical comparison. And that's why the twin who went zooming away actually will age less as compared to the twin on Earth. Since we cannot even consider Tsiolkovsky's journey to be a single frame of reference. The relativity works in a single frame of reference. Okay, so now as a brain teaser, consider this. There's a ladder whose length, let's say, is 5 meters and a barn whose length is, let's say, 4.5 meters. So let's say the ladder is moving fast enough for the effects of relativity to work on it, such that for an observer standing on ground, the length of the ladder contracts and now the ladder has to pass through a barn. So for the observer standing on the ground, since the ladder has contracted, it should fit inside the barn. But for an observer moving along with the ladder is not contracted. In fact, the barn has contracted even more, so the ladder should not fit. But then, did it fit or not? Who's right? Now, this is called the ladder and barn paradox, and you can comment your answer or what you think the answer is, who's right, in the comments down below. Well, I know that this video took a long time. Well, again, it's relativity. Well, it might have been that it took just a week for me, but since I went zooming away, time dilation took place, and I'm Tsiolkovsky who went zooming away. I came back, I aged less, you guys aged more. Yeah, lockdown's only been going on for a week. I've become lazy. I went zooming away, and you peasants stayed here on Earth. That's why I aged less. Time dilation, guys. Now subscribe, little farmer. Subscribe if you want to go in space and age less like me. You're going to space, you age less, lockdown's gonna go faster. Subscribe. Yeah, you subscribe. And well, guys, another reason that this video took a long time was because I was collaborating with this channel called Bexar Outfitters, and check it out. Yep, it's got great content. And for the video which I helped him with, you should check it out for sure if you like my content.